That you don't have credit cards. Oh, and you already have credit.
Hello, everyone, and welcome to GPTuesday, where we bring together the AI community here in Miami and around the world. I want to give a small apology for being late today. Because of the storms in Miami, I flew in just an hour ago, so raced over here to help finish setting up. I want to thank the team here at GPTuesday. Vital, thank you so much for helping get everything ready. Really appreciate that. Really made this event much better. So without further ado, what is GPTuesday? GPTuesday is a weekly AI event where we bring together engineers, entrepreneurs, researchers, programmers, and people just looking to learn more about AI, all together so that we can continuously learn from one another, just so that we can stay ahead of the AI wave of change, because things are moving so fast. So because of great people like Patrick, we're able to stay ahead, learn about different models, learn about how to integrate this stuff into our workflows and into our projects and companies. So I would like to give a quick shout out to our sponsors. We have our wonderful sponsor, the Hub here. Every week they allow us to come together here so that we can help bring education to the AI community and for people looking to learn more. So great thanks to Noel and the Hub. Over here you can see the beautiful desks. I'm actually working out of here as well. So feel free to get a desk, an office, or anything you like. And also we got a new sponsor. If you want to, yeah, what was it?
JLI or something?
Yeah, can I grab this real quick? Yeah. JLI, right? Amazing. Yeah, JLI, right? Yes. So thank you to our sponsor. They're doing amazing. So really appreciate that. Really amazing drinks. And without further ado, I would like to, before I take any more of your time, let's go ahead and bring Patrick Devani up to the stage, where he's going to be talking about how to use and build a sentiment analysis model for business impact. So take it away.
All right. How's everyone doing tonight?
Woo! Yeah.
So I'm excited to present this sentiment analysis model for business impact. Quick little blurb about me. I'm an FIU student, and I've done different things in like blockchain, the hackathons, and experimentation. More recently, I've gotten into machine learning and building different models, fine-tuning on llama-style language models. In this case, we're going to be working with TensorFlow and Keras, which are two libraries for building sentiment analysis models and other AI models. But excited to present to you tonight. All right. So what is sentiment analysis in the context of AI? We're going to be using natural language processing, text analysis, and linguistics taken to the computer world. Sentiment analysis models find and measure people's feelings and opinions of text. The basic models have three ways to divide the sentiment: positive, neutral, and negative. And then more advanced models can identify emotions like enjoyment, anger, sadness. And the significance is that we're trying to analyze like customer reviews and get better like A/B testing for products you release. And in this case, typically like words are given numerical scores of like -10 to +10, and that tells you the sentiment strength. So what are some common applications? Well, like I was saying, you analyze customer reviews and survey responses. You monitor the online social media content like Twitter posts. That way you can get like a gauge for responses if you have a lot of commenters on Twitter. And you can enhance your marketing strategies. And it can even be used in medical settings with matters of like bedside manner and reports. And this is the problem. How are you going to read through like 700 comments? Or how are you going to get through reading a lot of negative comments if it's a bad product release? Why can't you just get a machine learning model to do it? So what are some solutions that we could use if we don't want to use coding or machine learning engineering at all? Some companies that offer this service are HubSpot Service Hub, Sprout Social, which focuses more on like social media marketing campaigns and influencing. Wide Whale, TalkWalk, Idiomatic, Meltwater, and Lexalytics. And if we want to work with open source Hugging Face models and give a try for them, we can use some of these on Hugging Face. I'm just going to pull away here. Now, we all heard about the stock market not doing so well recently. If we take this text right here, and then we go to this model right here, we have an inference API. So we can try this model and get a sense of the percentage of how negative the message is, how well the model performs. And it's returning mostly negative, as you can see. So if I go back to our slideshow, there are different models for like crypto market analysis, like I said, tweets, Amazon reviews. And one of the things we have to focus on when we're working with sentiment analysis models is objective sentences versus subjective. Objective means like factual statements, like water boils at 100 degrees Celsius. And subjective could be like, that was a terrible experience, or this is really good coffee, right? So what we're focused on is those subjective sentences and trying to weed out the objective sentences from our calculation. What are the challenges? Context. So word meaning can change on context, and there can be subjective uses of words that might, or even phrases that sound objective, right? And you can have the mixing of objective and subjective sentences. We can have metaphorical expressions and idioms, different languages. So we don't really know exactly what would be objective and subjective, right? And then different writers can have different writing styles. Some data can be like out of date and have a very different cultural context. And there's also, especially with manual analysis or manual annotating of data sets, it can get very expensive with large data sets. So what are the actual like algorithms that we're going to use to possibly work with these machine learning models for sentiment analysis? One is called support vector machine, and it categorizes them into positive, negative, and neutral, right? Then we have something called a feature space, which maps text data into a high-dimensional feature space. Don't worry about that too much. We're going to talk more about how that works. But the important thing to know is that there's a decision boundary, and it's a line between like the positive examples and the negative examples, and that line determines whether it might be positive or negative. The examples on each side. There's another method called the bag of words, and what this is simply is we convert words, sets of words and subparts of words into something called a token, which is important for natural language processing. And we only focus on like the word presence and frequency. And it's a little bit limited with the semantic meaning of words, but it's most popularly used for like classifying emails as spam or not spam. But more importantly, we're going to be working with neural networks. And what makes deep learning versus shallow learning, like linear regression, is that we have multiple layers of how the data gets impacted. Basically how it gets transformed from an input when you're training it, and when you're running the model to try to like learn and predict new data about a data set, right? So it's more complicated essentially than these other models I mentioned. And we're going to be using a little bit of convolution. It's commonly used for like image analysis, computer vision. And we take words and we're going to basically turn them into numbers. That's what embeddings and vectors are. And some of the foundational models in the space, like BERT or Roberta, are really adept at understanding the context and meaning between words. So to review, SVM is simpler. It requires manual feature extraction, and it's better for like small data sets and more simple machine learning tasks, right? Bag of words is very simple. It's easy to implement, but it's not super accurate. And the deep learning models require the most computing, but they're great because they have very good accuracy and sophisticated understanding, right? So here's just some screenshots of a case study, a real world case study of product reviews on Amazon for Apple phones in India. And you can see a lot of these initial ratings here have like a rating of 5 and a review. And there's that coupling between there's a review and then there's a rating number. The number we want to convert to another data type, but the review is obviously very important because we're trying to interpret reviews, right? And don't worry about this, but this is just like an example of how these academic case studies and business case studies can be used in the real world and the impact that these models can have. So pop quiz. What is stored in the vector when using the bag of words?
See?
It's the frequency of the token. So we're going to work on building our own model. And I'm going to go through this a few different ways, but I think that you'll be able to learn a lot. So it's a sentiment analysis model using TensorFlow, scikit-learn, pandas, NumPy. These are all basically what's called like a library for Python. So to explain it for some of my less technical people, maybe it's like it's extra software you add to Python so you can do more things with it. And it's very practical to import these and get more complex uses for your program. It's got more sophisticated, like complex theory, but I'm going to show you kind of like the ways that you can just work with it and not have to worry about that. So what's the first thing we have to focus on is the concept of the tensor, which I mentioned a little earlier. We need to make a text sample into individual words and divide those words, right? We need to transform the words into what's called a tensor or a vector. In this case, we'll refer to it as a tensor. So you know, like on a map, you have geographic coordinates, right? You might have latitude and longitude, or a table has like a row position and a column position. So a tensor is kind of like both of those things. Like a 3D space has like position in 3 dimensions, right? This is hard to visualize, but it's the same concept where a tensor will have many different dimensions. Can you hear me better?
Oh, much better.
All right, thank you. So basically, each of the dimensions in this model for the tensor, it's like the building block of our machine learning model. It's going to represent the different features of a word's meaning, because a word can have many different meanings in it. Sometimes it has like one meaning, and the difference in position, so to speak, or the numerical value between all these words represents the difference between the words. And if they're very similar, then that means the words are very similar. You know what I mean? Like dog and canine would be very similar words in their meaning. So we don't have to worry about this too much, but technically, how could you view a tensor, like graphically display it? You would have to reduce its dimensions to like 2 or 3D, and you might use something like distributed stochastic neighbor embedding, which is just a function that you can use with TensorBoard. So it's really just like software ways if you want to view the tensor. To get the model working, we don't really need to worry about this, but you can use TensorBoard or Matplotlib. And then you have to look at, like I said, the distance between the words, clusters of words, and that kind of tells you the differences in their meaning. So one more way to view a tensor might be a one-dimensional tensor is just like a line. And like each of these means where it is in the line. Or 2D tensor might be like a map, the coordinates, like geographic, 3D, a space. You can also think of a 2D tensor sort of like a table, like an Excel table. And then of course 4D, you have the 3D, but then you have all these different positions, and it gets harder to visualize. But anyway, the key point is they store the meaning of the data type, and they implement the meaning through a sort of geographic coordinate in a complex space. And you need more dimensions with different data sets if the data is more complex. But they're used in almost every AI model we use today. So now I'm going to just go through some of the high-level steps that we're going to do in our machine learning model. I load the data set with a Hugging Face Datasets API. Then I convert the data into a data frame, which like stages the data. All this means is I'm just downloading the data from like a cloud area to the app I'm running it in. And then we're going to get rid of the column that has the number for the review, because we're going to convert the ratings into sentiment labels, like positive, negative, neutral. And we just shuffle the data set so that it's a random distribution. We have this tokenizer, which is going to convert the words into the numbers for data. We're only going to focus on the most frequent 5,000 words, and any words that we can't deal with, we'll replace with out of vocabulary. And then we're going to make sure that all the sequences have the same length. So it's got to be like 100 words. If a sequence is very short, like a sentence, we're going to add zeros. And then we'll truncate really long ones. We'll shorten them. We'll cut them off. The reason for doing that is because these machine learning models, where they manage memory, they just need samples that are equal size. So we create sentiment labels, like I said, positive, negative, neutral. And then we're going to split the data set into like a training set and a testing set. The training says what the machine learning model is going to be dealing with when you're training it. But the testing, it's like you want to make sure and validate, does it work right? And that makes, like I said, it makes sure that it can adapt to new data. An example.
Patrick, I think you have to speak like directly to the top of the mic.
Oh, sorry.
There you go.
Okay. So, moving forward with this example, we're going to just use a sequential model, which basically like layers, these different layers of the neural network. Then an important layer is the embedding layer, where we convert it into vectors. There are 64 different filters we use, so they're going to look for different patterns of meaning. And then we just have this global max pooling one-dimensional layer, and it just simplifies and retains the most important of those features we got from the convid sort of layer. And we have a dense layer, and we're basically going to learn the complex patterns. The dropout layer does something, it prevents overfitting. And what overfitting is, it's just like your model might work well on like the basic data that it's worked with, but if you expose it to new data, it performs very poorly. You don't want that, of course. And then we have the sentiment categories. And then this function in the output layer that I talked about represents the probabilities that it's going to be neutral, positive, or negative. Lastly, we have the atom optimizer, and the loss function measures the difference between like the probability, and then we evaluate how many correct predictions there are. So I talked a little bit about it. We're actually going to go now to the Colab file, and just forgive me if I repeat a little bit. but I want to explain this in different ways so that you can understand it very well. So in this first cell, if I reconnect to this runtime in Google Colab,
And can you zoom in a little bit?
let me. Let's see.
Let's do one more.
Right there.
Is that good?
Yeah, that's good.
Great. So in this first cell, we're just going to be installing our dependencies. TensorFlow is the environment where we're going to be doing all this machine learning. It's going to make it happen. Scikit-learn and Pandas are other like data manipulation, machine learning libraries. NumPy basically does numerical like scaled calculations. And then, we have what I want to focus on is the tokenizer, which is important to convert the text into numerical data, and the padding. Then we have the sequential model, like I talked about, and then we have all these different layers. And we're going to run this. And that won't take very long. Let's keep going. All right, so we're going to import our data set. And I stored the data set on Hugging Face. I just think their API is very clean to work with. And then we're going to make a data set called train. We're going to print the first part of the data set. If you want another look at this data set real quick, I can just go here. It's hotel reviews from TripAdvisor. So you can see we have a rating, and some ratings are poor, some are good, and they give different stories about how their experience was. So I'm going to go back here, and now we have the head of the data set that we've shown. So now we have to pre-process our data. We're doing this right here. We have the data frame, which has a review column and a rating column. And the data frame basically is just like, it's taking your data set and then it's staging it like a table inside this program we're running called Jupyter Notebook. Does anybody have any questions so far? All right. So we got, we're going to convert the number ratings to the sentiment labels. And if the rating in these hotel reviews is more than 3, the sentiment's positive. If it's less than 3, it's going to be negative. And if it's equal to 3, it's neutral. And it's easier for our machine learning model to work with this set of 3 different categories than it is to work with all these different numbers. And these categorical labels work very well. We have review words, sentiment as a relationship. And then you can see I explained it, but here's the function that implements that. We get rid of the ratings column, and then we shuffle the data set so it's randomly distributed. All right, so now we have to tokenize the data set. We have the tokenizer here, and it basically says the amount of words is going to be 5,000 different tokens in our dictionary, right? Any other words that are like very rare, they're just going to be ignored because they're not really useful to understanding. Data science and machine learning requires a lot of frequency and a lot of pattern building from common data. So, it's going to skew if you have rare data. Then we have the requirements to fit the data on the text. We talked a bit about like overfitting. And it scans through the text data and counts the frequency of each word, and then it sorts the words and ranks them by their frequency. So then they each get a unique ID based on that ranking frequency. And then we're going to convert the text reviews into the sequences of numbers, basically the tensors that I talked about. And then with padded sequences, we have to make sure that it's not too short, it's not too long. It's always going to be 100 length. And I'm going to run that. All right. So here we just basically turn these different columns of positive, negative, and neutral to what's called like a Boolean. What it means is that like if the rating is neutral, we're gonna have a value of 1 in the column, and then false or 0 will be for positive and negative because it's only neutral, it can't be both. And I'm gonna run that. And this is the function where I split the data set into training and then testing. And the test size will be 20% of the whole data. So here's the most important part, in my opinion, because we're building this model from scratch. We're not fine-tuning like a foundation model. We have to understand each component, how it works. I talked about how the sequential model lets you have like a linear stack of layers, meaning that it's going to go through one of the layers before it gets processed through another layer. And we have the embedding layer that converts the words into the vectors, 5,000 different words, and there's 100 dimensions of meaning for each. So then we implement it like that. And the input length determines how much the length will be of like input for when you're running the model itself, not just training. So I talked about convolution one dimension, and it slides over the text data. So here's like a very simple example of how it works. There's a filter, there's multiple filters, but we just focus on one as an example. And the filter has this like comma separated list of numbers. Then you're gonna multiply those numbers in the filter by the token. So the token is every single token, like in the data set. And we get a result, and it's gonna be these numbers. And the final thing it'll do, it'll sum all these numbers. And to make a long story short, it will find the important patterns in the data. So then another thing I want to note is that we have the 64 filters and 5 values in the filter. The ReLU activation function, it means rectified linear unit. And basically, we're going to, if the model has negative values that it finds, we're going to just make those 0. And this makes like the model more complex, so it can learn more complex insights. All right, so we are also adding like a dense layer. The dense layer is basically the ultimate like brain of the neural network. And we're using the ReLU activation function again. I also want to mention the max pooling one dimension. Like I talked about, it just lowers the data set size and the complexity by keeping the most important like insights it learns between different words and patterns of words. And then finally, we have the dropout layer, which prevents overfitting. And then we're going to add the output layer. It's a layer with 3 output vectors, and those are going to be the positive, the neutral, and the negative result that we get, right? And the function I talked about is called softmax. Softmax basically gives you a probability of whether it's the negative, the neutral, and the positive one. So then we just compile the model. We use this Atom optimizer. And so I'm going to run this. And it won't take long. Some machine learning models take very long. They require a lot of computing. But we're kind of working with a small model here. We can see it training through different epochs, which means how many times it runs through the data set. The data set size is only 15 megabytes, so that is a lot of words, a lot of samples, but in the context of like machine learning and how big the examples get, it's very tiny. So we finished, and we have an accuracy of 0.83, so like 83%. Right now, I'm going to click this to save the model, and you can load the saved model right here. And then we're going to define how it's going to predict the sentiment. We can run this one, and it gets positive. It gets negative, and sometimes it has inaccuracies, like average, it leans towards negative, but
For the audience, what are they saying in the sentences?
oh, sorry. So the first sentence was, I love my stay at the hotel. That was positive. And then it said, like, the second one, I hate the product, I'm never going to buy it again. So, of course, it was negative. This one said that it was an average experience, which should kind of be like neutral. But, you know, it makes a mistake because it's a smaller basic model we're demoing.
Quick question.
Sure.
If there are two sentences, the first sentence is I love the stay in the hotel. The second is like I hated how the staff treated me. I love the room service, whatever. But so what is it going to be neutral or something else?
In this case, it delivers like a probability, and then it like leans towards like one or the other. So it might give you overall like positive based on how it calculates. Because there are more sophisticated models, like I said, where you can like say, what was the percentage of positive and negative? And there's ones where you can say like, how much more, like, is it sad? Is the person happy? Like you can gain all those insights. And once you have these different samples, like if you can batch run reviews through the model, you have more data, you can do more with the data. So how can we deploy this model? How can we work with it now that I've like built it and run it? We have this file right here. I could download it. In this case, let's see, download, block the download. Let me try again. All right, so in a moment, we just download these. I go to my download folder. And here's something called Hugging Face that I talked about. So Hugging Face has something called a Hugging Face space. And it's a way that you can, like if you build a language model or you fine tune a model, any kind of AI model, they will run it in the cloud so anybody can access and use it. It can be free. The only thing is like it uses a CPU, and that's a lot slower with AI than like a GPU, but it can still work if you need to demo something. So I can give you an example. We'll call it like sentiment demo right here. And then I'm going to go use the Streamlit. And then, yeah, we'll just make it public. Next step will be to take this right here. Let's see, yeah, get clone. All right. I'm going to go here. And I'm just going to use this thing called git bash. I'm going to say git clone. So now we have like the same file that can connect to that file in the cloud. And I'm going to go cd to sentiment. All right, and then we'll just say code this. So I'm going to go, we got index. I'm going to take these and moment. We're on the desktop. Demo. Let me just grab it via we go. And then demo. I'm gonna basically just add these few files here. We're gonna look at the repo. So this is like the Streamlit, and it's like a Python app that renders a front end. So you can just like serve the model like a basic chat, right? And here's our predict function that we use in Jupyter Notebook. And now we're going to go back to here. We're going to say git add everything. Git add demo. All right. Git push. So now I'm going to look here. And we are building the app. So that might take a moment. But you can see that it's downloading all the dependencies. It's going to run it for us. So I just wanted to kind of do one more quick run through the different layers because it's important to understand in the context. This definition here in yellow is like the actual function, how it's implemented in Keras, which is a library we use. And to explain it in a few different ways, we can stack the layers of the data set linearly. We have the embedding, which tells you like the size of the vocabulary, all the words that we're processing. And then we have like the dimensions, how complex the data type is going to be represented, which is a text, right? And its meaning. And then we're going to make sure it's always 100 tokens, like the input, when we're training in batches. Then we have the 1D layer I talked about for convolution. And it basically creates like a filter that slides over your input data in one direction and creates new values. And if you have an activation function, it changes the outputs to help the model learn better. And we have the filters to tell you the dimension of how many filters there are to look for different meanings of words. And then we have kernel size, and that tells you like the window that I talked about, like a magnifying glass that slides over the input data. And then we have the ReLU function, which returns 0 for negative inputs, and it returns the input for positive inputs. So instead of linear data, it makes like complex, nonlinear shapes of data.
We have a question from the live stream.
Sure.
One of the questions would be, from a usefulness perspective, how can fake or misleading reviews be excluded?
So I think that that boils down to using a very large data set and careful choice of data set. If there's like a reason to suspect that there are like malicious reviews like from competitors, I think that the size of the data set will normalize the data.
Got it. Thank you.
So in any case, I put both technical like definitions and I put non-technical ways to explain this. But basically, we convert the words into numbers. Then we take those numbers that the computer understands and we try to look for patterns in the words and patterns between the meaning of the words. And then the machine learning model captures those insights, keeps them, and it's very important for it to understand these sentiments. And then we have the same function here from Keras, where it reduces the dimensionality of the output so that the data is just not too complex to work with or take too much time or too difficult to interpret. And there are two methods you can use here. One's called like the data format. To make a long story short, we basically have like batches of different data that the machine learning model processes. And then we have like the steps and the features. And the steps are like how much it interprets like each token.
Could we zoom in just a little bit?
I'm sorry?
Could we zoom in?
Oh, yeah. Yeah, they kind of drop off.
Thank you.
Yeah. So then we, if we keep the dimensions, we keep all of the dimensions. Like I said, that could be complex. We have the dense layer, which is like the nexus of everything. And the inputs that come from the previous layers are multiplied by a weight. The weights are summed and added together, similar to the convolution layer. And then there's a bias added to the sum. And then sometimes there's an activation function to decide the final output. But every input basically talks to every output. The inputs are multiplied by strengths. You add them up and you adjust for bias. And then you apply a function and get the final result. The dropout layer, like I was saying, is basically to prevent the overfitting. And I wouldn't really worry too much about it. It's just that like 50% of the data might be converted to 0 to prevent the overfitting. And then the dense layer is just the dropout layer. And the units in the dense layer refers to the number of neurons. The dimensionality is determined by how many neurons there are. And I talked about the softmax function, like it basically decides the probability of each case, negative, neutral, positive. So we can see a summary of layers here, numerical vectors, local patterns, combine the patterns for overall sentiment, and then of course the output layer. So we compile the model, and this is where the model builds, and we use Atom Optimizer to reduce chance of error, and it updates the weights as much as they contribute to error. This categorical cross-entropy loss function measures the difference between predicted labels and the true labels. It's good for problems with multiple classes. And then we just have the epochs, is how many times it trains for the data set, and the batches define how quickly it trains, like how many bits of data that it deals with. So I talked about model deployment, and I gave the example how I did it right there, that you just go to something called git bash or a terminal, depending on if you're on Windows or a Linux operating system. You clone your space, then you add all the files you need to serve the model as like a web app. You commit the model, and then you push it. And again, here's the Python server. So pop quiz, what's the purpose of the one dimension convolution layer? It is the. So next thing we have to talk about might be like foundation models. Before I talk about that though, I just want to show you how the live demo might be. And then it's running. Let me just see that right here. Okay, I made the error of not uploading it. The solution, I didn't actually upload the model, I just uploaded the server, but I have another copy. And this model is a very small model, and it doesn't always give good accuracy. So that's why I'm moving on to more of the large scale models, the foundation models. And the main one that's been talked about in the last few years is called BERT, the bidirectional encoder. We can look at a couple other models. One uses NVIDIA's architecture, and one uses Google's Vertex AI. And let's tie it back to the key business applications. You can use this for customer feedback analysis and responding to like poor experiences people had. You can monitor how well your brand is being received on social media. You can research the market, what the sentiment is in the market. You can improve your customer service. Here's some real world examples. You can analyze what your competitors are doing and how they approach marketing. And it can be used for different things like crisis management, product development. Here are some real world use cases and example links. I won't necessarily go through all of them, but I'll just show you some examples. Like this one right here. It's kind of an older example of a sentiment analysis model they have on GitHub that can use batch processing. This is what I talked about, where you can process hundreds of samples in like a batch file of data. And that way you get a very big data set of how your product's being received. So let's see. Here's another demo of a different model. And I apologize for the inaccuracy of the model, but I think it's just an issue of it being like a very basic implementation. But this one might give you more sophisticated sentiment. So we can just run an analysis here. And it'll give you like a spread of, is it positive, how much it's positive, the magnitude. And how's everyone feeling so far? Okay. Would you be interested in seeing some more models, just how they work in Colab, or how are you for time?
Yeah, sure.
Okay.
Get some demos. Pretty cool.
All right. So here I have NVIDIA NeMo, and we're just going to be looking at their platform. They use a Stanford dataset on sentiments. So this file, I'm going to connect here, disconnect here. So I'm going to run this. And then some of these are for like local training, if you've got like on-premises hardware. But I'm just going to focus on what we need to do just to run through this model. So we're using PyTorch here, and we're using NVIDIA's inference engine called NeMo. And you can see in this output here, it's like collecting all of like the different software we need. With Google's Colab environments, like it provisions like a computer for you to work on, but there's nothing saved on it. So it has to do this every single time. There are other platforms like Kaggle, and there are other cloud services where you can like train if you want to do machine learning. And I'm going to just kind of run through these quickly. And then we're going to set up big training. And then we're going to just run all these cells. Use a basic vert model. And then let's see, initialize a model. Start the training. And let's see what else. We can evaluate the model. Run inference. And then the last step would be to deploy it. But in any case, you can see there's some curated solutions. If you want something that already has some code and you can sort of do it yourself, but you also leverage the tools that like NVIDIA and other big tech companies provide. I'm just going to see how the longest part of these processes can just be like downloading the software. And then, of course, if you're writing your own code and you have to debug it, that could be like a real roadblock, right? But maybe I'll just have that run in the background. We'll just take a quick look at the Google Vertex AI version. So Google has their Google Cloud platform and Vertex AI. So we can just install some upgrades. We can run basically 2 runtimes, multiple runtimes if you have like a paid version. Maybe I could get a couple T4s here. Do better. Right. So I need to download the data set here, and I need to import OS. Cells, but let's see. All right, so I think for the sake of time, just for everybody's attention, there's a little bit of issues with these collabs, and we might need to like define the data set we need custom. But it's just a great way to show you that there are different tools that you have that already do some of the work. And I'm happy to take any questions now. Sure.
Have you ever heard of a company called Canvas AI? CANVS.ai?
I think so, yeah.
Yeah, they do. I used to work for them a long time ago before they were in that. But I remember one of the things I was working on was scoring words in terms of their, how far apart they were. And so one of the things they do is figure out emotional intelligence, like how emotions are impacting what you're saying online. So, like for example, we did work with HBO. And Game of Thrones was just starting at that time. So we would analyze how people were talking about it on Twitter and across social and how emotionally impacted they were, especially within different scenes or spots within an episode. I'm just curious if you know anything about that.
I'm not too familiar with it myself, but I'll definitely take a look at it. Canvas.
Yeah, you should. CANVS.ai. They're doing some cool stuff. I haven't really been in touch with them for many years, but that's what they do, and it's pretty cool. So.
Okay.
The other thing is, I've built some cool stuff using Cursor and Claude Sonnet, and without knowing how to code at all. And I've built full-on products, which is pretty cool, and I'm continuing to work on them. And I think everyone should try this stuff out because it's freaking incredible. And you don't have to know how to program to do this anymore. You need to know how to write English and try things over and over again when they don't work and figure out how to make it work. But you don't need to know how to code. So there's that. Yeah, I'm happy to speak. I'd love to. I work out of here sometimes.
Awesome. Thank you.
Thanks.
Any more questions? 1 second.
Sure.
Hey, what's up? I'm very curious. Why did you use TensorFlow instead of PyTorch?
In this case, I just wanted to try something different. I've used PyTorch more frequently, but I like the way that the curate API is pretty straightforward.
Interesting. And what did you say softmax does again?
Softmax, when you're outputting the probability, it like defines whether the probability of the words be negative. It sums to 1, right? So like you might have one that's like 25%, 0.25, one that's 50, one that's like 0.25. Maybe there's a tiebreaker for it to be like 51%, and it would output like neutral if that's the probability.
So do softmaxes intake negative numbers, or is it only like it'll intake negative numbers, but the output is always going to be positive, right?
Yeah. Because it has to sum someone.
Interesting.
So for no code like a bubble, how do you integrate Vertex AI with Google to what's the API that they can use?
All right, so we could look that up. So for Vertex AI, they have different no-code solutions. So I was talking about AutoML, and with different platforms like NVIDIA NeMo and Amazon SageMaker, for example, Vertex AI, they'll take a foundation model like BERT that I showed and talked about a little bit, and they will let you fine-tune it or adapt it to a task. And I think that it's going to be more through like the Google Cloud platform, through the console. But I'm most familiar, I think, with like Amazon SageMaker has like a very wide suite. I also experimented even with hosting this on AWS. The only thing is like you have to be watching out because they tend to be pricey. So.
Do you have any recommendations for forums or discords or anything of that nature for like beginners? Is it all are there general places where basically do you pick a tool and then you get into their ecosystem? Like what would you recommend as a next step?
So what I really liked working with was something called Hugging Face that I showed, because they are like the Times Square of like everything AI. So like a GitHub. GitHub is like just for coding. There are a few different discords because there's a guy named The Bloke, and like he's basically like a developer on Hugging Face that will give people the model weights. So the model weights is basically just the model, but like in different formats. Like they'll do a service to like make different formats available for different runtimes, right? In the Telegram, I'll post some more of the forums that I think are good.
Thank you.
You're welcome. And just before we go, I wanted to show you guys the Keros API model documentation. So you can see here, everything that I talked about, basically the layers API is where you can derive this from. I go to convolution layers, for example, convolution 1D. You can find the more formal definitions and more information on their website. Any more questions?
Who had a question?
Any more questions? I think that's it.
All right. I want to thank you all for coming. Massive thanks to Grant for inviting me to speak. Thank you to Todd for helping me set up. It was nice to meet you. I really appreciate your help. I want to thank everybody for coming out because we need the community to make this happen. And if you want to connect with me on like LinkedIn or Twitter, here's some QR codes.
Very amazing. New week here at GPTuesday. Patrick, thank you so much. You really taught us so much more about sentiment analysis, how to build a model, how to deploy a model, and now also, how to use it ourselves in our day-to-day business and in our general workflows. So again, another round of applause for Patrick. Thank you so much. We really appreciate it. That's what we're trying to do here every single week. We want to bring people from the community, from around the country as well, to speak here to continuously teach us on a wide variety of topics, whether it's research, engineering, business, right? So we'll have a lot of different flavors. And this one was a great technical deep dive, but also a great explanation of how to use it in our businesses, right, in our workflow. So again, thank you again so much, Patrick. What we'll be doing after this is we'll go ahead and show on the Telegram. We'll be showing you our Telegram community group on the screen here. You can just go ahead and take a picture. You can go ahead and just click that QR code, join our Telegram community group, ask any questions you want, and just get to know us every single week. We're here every week, so you know where to find us. Feel free to grab a drink in the back. And again, thank you all so much. If you may, please, the community here is what makes us thrive. So if you can go ahead and just tag us, mention us on social media, Instagram, Twitter, LinkedIn, you name it, we really appreciate it. And thank you all again so much, and let's just have some great conversations now. Woo! Woo. Go ahead and we need some music in here. Oh, and one last thing, we actually do have a very surprise, a really great event tomorrow. I would love to bring Alex up to the stage right now, please. Yep. We have a great event. Alex is going to go ahead and just share what we're building, what Alex is building here in Miami.
Hey people, I'm Alex. Don't have a name tag, but tomorrow we're doing an event called Software Internals at Society Wynwood. It's an event for engineers, technical people, researchers, developers. I encourage you, if you're any one of those, you should come, or not. You should come. We're going to be doing like more technical deep dives, even equally, if not greater, than Patrick's demonstration tonight. Thank you. Hopefully, I'll see you there.
RSVP.
Oh, thank you. It's 6 to 8 p.m. at Society. Just come to me after this if you want the details. It's on Luma. You go on lu.ma under the Miami tab, and we're also going to post in the GPTuesday Telegram. All right. Thank you.
Thank you.
Thank you very much. Alex has been just an amazing person, a bulwark of our community. He's been here since the very first day. I think you might have given the most presentations here as well.
Maybe.
I think so. I think around 5 now, but always so brilliant, right? From vector embeddings and different kind of games you can build with them. Just really, really great, warm, awesome person. So definitely check out Software Internals tomorrow. It'll be a lot of fun. And yeah, just have a great time.
One more event. We have a holistic wellness event and networking for tech people in wellness to kind of, combine those communities together. This is taking place August 8th. What day is that? August
Coming up.
Thursday.
Yeah.
Thursday from 6:30 to 8:30. We'll also post that in the group, but could you share more details about that?
Yeah. Hi guys, I'm Larissa. I do Wellness Wednesdays here, and I think it's beautiful that I stepped into this space and I got to learn about tech. I program my own GPT bot, and I am not a tech savvy person, and I'm trying to work on developing an app. But I think people like me should learn about people like you. So if any of you or anybody you know would be interested, connect with people there and see how maybe their ideas can be developed into something technical as well, and kind of build that merge or gap between wellness and tech. So 6:30 to 8:30. Love Life Cafe in Wynwood, and I hope to see you guys there.
Woo! Thank you so much. All right, we'll go ahead and check that out, and let's put the Telegram on the screen, and let's have some great conversations. Thank you, everybody.
Awesome. Cool. Nice. Amazing. Yeah, I can get some music out. Yeah. Yes.
We'll probably end the stream.
Yeah, right. No, let's get this view.